Hello, everyone, and welcome to Passive House Accelerator Live, where we explore how to slash the greenhouse gas emissions from our buildings and make them more resilient to the impacts of climate change. I'm Zach Simke. I'm director of the Accelerator, and we are super excited to have Ed May join us today to introduce the Honeybee-PH suite of tools for us. Our host of today's Next Up episode is Carmel Pratt of Bright Power. So with that, Carmel, please take it away.
Thanks so much, Zach. I finally feel like I can say this. My next guest needs no introduction, but I'm still going to read your bio, Ed. Most of us know and love him and have learned a ton from him. And we're so grateful that you're with us again today to show your Honeybee tool. Ed is a licensed architect and a lead green associate. He received a Bachelor of Fine Arts from the University of Massachusetts at Amherst in 2001 and a Master's of Architecture from Parsons, the New School in New York City. Ed has been an adjunct professor at Parsons, as well as an industry professor at Stevens Institute of Technology in Hoboken, New Jersey, where he directed the 2015 Solar Decathlon program. In addition, Ed teaches with the Passive House Academy, the North American Passive House Network, and Passive House Canada, and is certified by Passive House Institute, PHA in Germany, and Passive House Institute of US, VIAS, as a certified Passive House consultant. Ed also makes a lot of amazing tools that we can all use in our practices. And that is what he's going to showcase today. So Ed, thanks so much. Take it away.
Fantastic. Thank you, Carmel. And thank you to everyone for the invitation to be here today. It's great to see everybody. Great to see so many familiar faces. So I'm going to be talking today about the Honeybee-PH toolkit. And before we get started, I just want to confirm, are you guys able to see my screen okay and hear my audio okay? Seeing some thumbs up all around? All right, fantastic. So let's carry on. So Honeybee-PH. A couple things I promise you about this lecture. I will explain where that name comes from. And we will talk at some length about the capabilities and the things you can do with this Honeybee-PH toolkit. So let's jump right in. Before, though, we dive into the actual tool itself, I like to start these discussions with a little bit of context. I think it's helpful just to kind of explain, mostly to explain like what my thinking is and how we arrived at these this toolkit here. And so we will, I promise, sort of dive in depth on the toolkit itself, and we'll talk about what you can use it for and how it works. But again, maybe to just start with kind of where we are thinking. This is a great quote from a paper, I guess it's old now, back in 2019, from the Rocky Mountain Institute that was talking at the time about the need for the imperative to retrofit and upgrade our building stock in the United States if we're serious about achieving our climate goals, our carbon emission goals. And they had a great sort of line here where they noted that in order to sort of move towards our climate goals, we would need to touch and retrofit about 5 million buildings a year in the US to something like a net zero emissions level. Now that doesn't mean passive house level per se, but a net zero emissions level. So just in the way of sort of context, that's the kind of number that we're talking about when those of us in the building performance industry think about or approach the question of the scale that we need to be moving at. So 5 million buildings a year, that's a lot of buildings. So, and basically it's half of all the buildings in the United States. So that's a little hard to kind of wrap your head around, but maybe imagine half of all the buildings that you see in a photograph like this. Now, this isn't the United States. I took this photo many years ago in Shanghai. But imagine half of all the buildings in this photo being retrofit to a zero energy level. And then imagine half of all of the buildings in every photo being retrofit to a zero energy level. So that scale is important to keep in mind as we start to talk about some of the tools and some of the things that we've built here. So 5 million buildings a year, it's about 113 million buildings total. And so if you want to retrofit 50% of them over 5 years, that's where you get that 5 million buildings a year number. So 5 million buildings a year is still a lot. That's still kind of a big number. It's not a very human scale number. So maybe we could kind of break that down a little bit. Maybe if you want to see it on a monthly basis, it's like almost 500,000 a month, or maybe more, a little more tangibly, maybe it's something like 13,000 retrofits a day in order to achieve our climate goals. Or if you prefer a slightly different way, assuming that there's, I don't know, 75,000 architecture companies in the United States. It's something like 70 to 80 zero emissions building retrofits completed every single year by every single architecture firm in the country for 10 years in a row. So again, before we jump into the tools, I think it's helpful to kind of keep this context in mind. So these are the sort of facts and figures that rattle around in our brains as we approach these questions of what tools do we need as Passive House practitioners, and what is the scale of the effort that we're trying to undertake? Now, I believe, and this is just a belief, but I do believe that the Passive House framework could help us to achieve many of these zero emission goals. And I think I believe that the Passive House tools could provide really valuable insights to lots of different teams that are working in lots of different ways to create better buildings. Again, we don't necessarily need to retrofit half of our buildings to the Passive House level of performance, but I do think the Passive House framework can significantly aid and assist the teams that are trying to achieve these different goals. So having worked in the Passive House space for 15 years now, definitely believe that we are big believers in the Passive House frameworks. We use them all day, every day to deliver lots of different projects, and I really do find tremendous value in them. But let's just, as a thought experiment, set aside the policy, the finance, the construction challenges. I know those are real challenges, but maybe just put those on the shelf for just a second and just think, if you are a designer or an engineer doing Passive House work, could you scale your Passive House design and engineering process to handle even the smallest fraction of the scale of need or projects that I just described? And that's an honest question. Could you? Could you do it well? Could you do it accurately and efficiently and quickly and on time and on budget? And I know for our own practice, the answer is definitely no. So we could not scale our own practice right now to achieve the type of scale that I just described. In my opinion, and this is just an opinion, so everybody here should totally feel free to disagree with me and yell at me and voice their own opinion. But my opinion is that one of the reasons, or maybe even the main reason, why I cannot envision our practice scaling to the level that I just described has to do with the current generation of Passive House tools. I believe, and again, just an opinion, that these tools are too difficult, too slow, too confusing, and fundamentally too disconnected for the potential of the Passive House frameworks to be realized at any sort of meaningful scale or at the scale that I just described. So that's my opinion, but let me try and offer a few data points to kind of back up my opinion, and sort of, again, put a little context around the stuff that we're working on here. I think, and I think the numbers bear this out, that the number of Passive House projects, while it continues to increase, and this is in no way to take away from the amazing and heroic effort of the Passive House groups and the Passive House practitioners and builders and designers, everything that people have done is amazing, but we are still way behind other similar protocols. So for instance, just to put a few data points to that, PHA says in 2024, they certified 130 buildings, 4.4 million square feet. That's incredible. That's amazing. But at the same time, something like AIA 2030 Net Zero had 270 buildings and 67 million square feet certified in 2020. I think that number in 2024 is up to like 450 buildings. I say, oh, but Ed, you can't compare those. That's apples and oranges. PHAs and Passive PHI are much more rigorous and more difficult than AIA 2030. Okay, fine. Yeah, absolutely. There's some validity to that. But I do think it helps to put some data around this question of where the professionals in our industry are putting their effort and what protocols they're gravitating towards. 67 million square feet versus 4 million square feet. We're talking about very different values here. On the people front, and again, this is just to provide some context for what we've done here. On the people front, PHA says, according to their website, that there's 3,000 CPHCs trained. There's 1,700 active CPHCs, and 10 universities have CPHC trainings. Again, amazing, right? That is a testament to incredible work done by the professionals working all day, every day, and sort of, really doing the Lord's work when it comes to the proselytizing around the FIAS and Passive House ideas. But again, put that in context. Other energy modeling tools, like the Ladybug tools that we'll talk about in some depth, have over 800,000 downloads. So at the same time that we have 1,700 active CPHCs, and we should be proud of that, we have 800,000 downloads of other types of energy modeling tools. Open Studio, which is another popular energy modeling tool made by or supported by the Department of Energy, sees 27,000 downloads every release. And another type of energy modeling software, Climate Studio, is used by over 300 different schools and different programs. So again, I don't mean this in any way to disparage or to criticize the Passive House community. We are doing great work, but it is important for us to recognize that we are behind. And for some reason, and we can talk about why that is, professionals in our industry are not gravitating to the Passive House standard and the Passive House tools at the same rate and in the same way that they are with other tools and other programs. If we sort of line those up, this is from the AIE 2030 protocol. They were looking at the top energy modeling tools that were used for their submission. Again, this is just one data point. I don't mean this to be, authoritative, but these data points are useful in sort of assessing the state of our industry. Something like Cove Tool, which came out in 2017, they've got over 700 million square feet of buildings using their modeling protocol. It's a very new program. It's a new tool. It doesn't have decades and decades of research behind it, and yet somehow they're able to get 700 million square feet of building modeled. Other really old tools, DOE 2, DOE 2.1, you've got 250 or 130 million square feet. And then you can see down at the bottom there, again, amazing that we've gotten to 4 million square feet, but it is a drop in the bucket compared to the rest of the industry. So when I see these numbers, when I see all these facts and figures, and again, you can quibble with any of those and say, oh, you can't compare commercial to residential and da, da, da. Sure, yeah, absolutely. But that does lead me to ask the question of why. Why are professionals in our industry not picking up our Passive House tools at a more rapid rate? Why are professionals moving to other tools and not ours? And again, I have a hypothesis here. Of course, I'd love to hear if other people have other thoughts on why that is. But I do think that a lot of the issues here can be placed at the feet of the current generation of tools, which, again, it's hard because I do love them. We work in them all day, every day, and I'm so impressed by those tools. But I do think it's important for us to recognize some of their shortcomings. So what sort of shortcomings? What do I think are the main shortcomings of the existing generation of tools? Well, they have significant usability challenges. So the existing tools, and some of us who've been working in these tools for 15 years forget this, but these tools are incredibly intimidating and complex for new users. The tools really don't logically build in complexity. There's a sort of uniformity to the inputs, and it's very hard for new practitioners to understand what the critical inputs are, what the secondary inputs are, how to get going really quickly and then iterate. And then very importantly, there still, even in 2025, is no meaningful interoperability between industry standard design software, Revit, and the existing modeling tools. And that is a significant stumbling block. It just is. I know it's a bummer, but it really is a problem for a lot of teams that we still don't have good connections between design software and our engineering tools. I also think there's a real problem when it comes to the speed. And the speed, when I say speed, I don't necessarily mean the speed of the tools themselves in order to do calculations. What I really mean is the speed of the feedback. So how do we as Passive House engineers and designers execute calculations and then get feedback to the design team as quickly as possible? I think the cumbersome nature and the complexity of the existing tools means that the design feedback loop suffers significantly. And there's, plenty of room for error. And as a result, design teams just don't get actionable or useful insight quickly enough within the time frame that can help them really design their buildings better. So we're sort of leaving something on the table when it comes to speed there. We could do a better job. We also have really significant shortcomings when it comes to connection, right? So none of the existing tools have any sort of automatic or automatable connections with, let's say, outside databases for material data, right? Is there an online database of material data that I can tap into that's updated, that has, product data sheets that I can automate the collection of? Yeah, I can copy paste things in, and there are sort of manual ways to do some updates, but there's no significant or really nice automatable product data set connection. And so it's very difficult to update the material collections or product collections. Fundamentally, everything's manually done, and that's really very, very difficult in order to keep things current. So we suffer from a lack of good connections between our software and others. We also have some real shortcomings when it comes to integration, right? So the existing Passive House tools, whether we're talking about PHI or PHI-US, are currently spread out across a multiplicity of different applications, different web apps, different standalone Excel calculators, PDF guidebooks for different protocols. I'm looking at you, multiple heat pump calculator and multifamily calculator and this and that and the other. And that's great, right? Again, I don't mean this in any way to take away from the amazing work that's been done to create those calculators, but having this distributed, disaggregated ecosystem of tools is very hard for new practitioners to wrap their brain around. There's a lot of room for error. And also fundamentally, the data protocols for these different applications don't speak well to one another. So we have to manually move data between these different tools. And that leads to long work cycles and room for error and all the other sort of problems we have with, manual operations. We also have just a lack of transparency with the tools. And by that, I mean a couple of different things. But fundamentally, what I mean is that and this is maybe more particular to my method of working as an outside consultant. As an outside consultant, we do all the engineering work for design teams. Those design teams just don't have a good window into our software, into the actual work of the Passive House models. So it's up to us to kind of repackage and deliver to them all of the information. So we don't have a good collaborative way of sharing these models amongst the entire design team. And then lastly, the tools here are really resistant to any sort of meaningful extension. They are not open source tools. They are not really well documented in terms of like how they operate. There's no sort of what we might call a software development kit or software developer kit. There's really none of that kind of supporting infrastructure that allows developers to create powerful extensions that improve the capabilities of these tools over time. Fundamentally, these are not community-driven tools. These are sort of, hierarchically deployed kind of closed source tools. Now, some of you Excel folks might object to that when it comes to the PHPP, but be that as it may. So there's a lot of problems, I think, with the fundamentals of the application. And then I would also add that the current generation of tools just really don't support the required Passive House workflow. So what I mean by that is when we kind of move away from design phase and we move into certification, it's important to remember that for certification, we have to have three distinct models. We have a 3D model of the geometry, we have an energy model of all the performance attributes, PHPP, WUFI-Passive, and then we have a third model, which is often not talked about that way, but is the document model, which is typically a set of PDFs that justify and explain every single one of the inputs in our energy model. That's a lot of data to keep aligned across three separated models. And this often leads to a lot of headaches and challenges and errors in the actual certification of Passive House projects. The fact that these three models are fundamentally disconnected from one another. And the only way to align them is to manually make sure that this value matches that value, matches the other value. So our current tooling really does not support this typical workflow where maybe I get a PDF from a window manufacturer that has a U value. I need to simultaneously add that to my building information model, my energy model, and my document model. And you say, oh, but Ed, that doesn't sound hard. So you put the value in three places. We'll multiply that by 150 window types times 27 updates to the project that occur over time. And you can imagine how these things can easily get out of whack. And that leads to, in our experience, many, many problems with certification. And so fundamentally, right, and I'm really just talking about my own experience here, we just see far too many issues or far too many comments like this when we go for certification. And you could say, oh, well, that just means that you're doing it wrong. And yeah, probably. I'm sure we could do a better job with our internal QA QC. And I certainly don't mean to say that there's anything wrong with these comments, right? So and so value doesn't actually match so and so PDF, right? That is an accurate comment, and that is a valuable thing for the certifiers to flag. What I guess I mean is that if the software was designed differently, these types of errors should never be possible. The software should be able to do the hard work of aligning all of these things and helping us as Passive House practitioners avoid a lot of these pitfalls. So that's my opinion, my interpretation of the current state of the Passive House tooling. And again, I'm going to stress this again because I know I can kind of lean that way, but I don't mean this as any sort of disparagement or criticism of the existing tools. Those tools are amazing. The work that's been done is amazing. I understand why they are the way they are, and it's not because anybody's lazy or doing anything wrong or nefarious. It's just a sort of function of how they've evolved over the years. And I do think, though, it is important for us to recognize those shortcomings. So that all leads us to several years ago in our office. We were struggling with all these issues, especially as our practice got larger. You know, we work on whatever, 50, 75 projects a year. There's only a few of us in the office. And so it's really hard to kind of keep all these things in our head. And so we were really looking for a way to automate and improve the data management in our projects. So we were curious about, and we didn't know if this was at all possible, or maybe possible is not the right word, but feasible. I'm an architect by training, an engineer. I am not a software developer. So I had no idea if it was possible for us to create these tools, but we really wanted to know or experiment with this question of, could we build Passive House modeling tools that are able to manage all the data, to handle a lot of these issues that I've been describing, manage the connections, and then just fundamentally get out of our way so that we as Passive House consultants could focus on and concentrate on the actual work of designing better buildings rather than pressing buttons and aligning values between two different spreadsheets. And that leads us to Honeybee-PH. So Honeybee-PH is the current version. It's our current best attempt to create a tool that satisfies the criteria that I just laid out. So Honeybee-PH is a free and open source toolkit. So 100% free, completely open source. It's not a product, it's a project. It's a free and open source toolkit for building detailed and flexible digital Passive House models. Now you might look at that, and the first thing that might pop into your head is, what is Honeybee? Why is it named Honeybee? Where does that name come from? Let's talk a little bit about that, and that'll sort of lead us right into a discussion of the software itself. Honeybee is not made by us. Honeybee is an existing piece of software. It is part of what's known as the Ladybug Tools. So Ladybug Tools is a company, another company that makes amazing free and open source building performance simulation tools. So Ladybug itself is dedicated to climate simulations, climate analysis, and climate simulations. Honeybee is used for detailed energy and thermal comfort, as well as daylight simulations. Dragonfly is used for urban scale energy performance simulations, and Butterfly is used for computational fluid dynamics simulations. All of these tools are free and open source. They've been around for a few decades now, and they are or I guess maybe only a decade. I guess 2013 was maybe when the first version came out. So a decade now. And they form together a really impressive and amazing package or body of work, which is widely used throughout the design and engineering industry for all sorts of different purposes. As I said, these different tools do different things. They're used for different things. Now, Honeybee is the part of the toolkit that's used for energy performance simulations. And so when we talk about Honeybee-PH, what we're talking about is an extension, an add-in to Honeybee that allows us to do Passive House modeling on top of that Honeybee toolkit. Now, why did we do it that way? Why didn't we like invent a whole new, protocol or something like that? Why did we choose to build on top of Honeybee? Well, first of all, it's because Honeybee is amazing. And the Honeybee and the Ladybug tools workflows and capabilities are quite incredible when it comes to both the simulations themselves, but also the data interoperability. So one of the main things that you get from working with the Ladybug tools is the ability to move your model in and out of all sorts of different calculators and modeling tools. And that, of course, is one of the fundamental headaches with a lot of the work that we do is how do I move the model data from this application over to that application, run a daylight simulation, and then bring the data back to this third application. And the Ladybug tools really, really helps us with that. They have spent the last decade working on these questions of software interoperability and have a very sophisticated method of moving that data in and out. And so what that means by building an extension to Honeybee is that we get access to all of these amazing capabilities, and then we add our new Passive House flavor. So we can do Open Studio hourly modeling. We can do radiance daylight modeling. We can do thermal comfort simulation. We can do detailed computational fluid dynamics, all from the same model, and then use that for Passive House as well. So building on top of those folks was important to us. I would also note, and this is a very important piece of the puzzle for a lot of teams, is that the Ladybug tools folks have a very nice integration with Revit. Now, for those of you who aren't practicing in the United States, maybe that's not as important, but if you're a United States or North American commercial practitioner in particular, the Revit interoperability is going to be very, very important. So the folks at Ladybug Tools have spent untold numbers of hours creating a Revit integration to allow you to move your building into an energy modeling tool. So they have a whole suite of different tools that allow you to grab data and pull it out of Revit and execute those types of Honeybee calculations. Now, we don't personally in our office use this much. But it is available, and it's an important piece of the puzzle for especially larger sort of commercial teams or the like, right? So that's a very important part of the toolkit. So, okay, so what are we really talking about? So what we currently have in the software here that we're talking about today is this Honeybee-PH. So this software allows you to take a building model. So maybe like on the left there, you have a geometry or a building information model for your project. And currently, again, not built by us, but built by the Ladybug Tools team, you have Honeybee, and Honeybee can take that model and you can run detailed hourly simulations using Energy Plus and Open Studio, get tremendous amount of data from it that way. You can use Radiance to do very sophisticated daylighting assessment. You can do external solar radiation calculations. You can do detailed thermal comfort simulations. So all of that exists. So when you build your model, you get access to all of those features sort of out of the box, as it were. Now, what we've added here, the new piece of the puzzle, is this Honeybee-PH component. And this Honeybee-PH extension now allows us to take that exact same model and push it off to WUFI-Passive and PHPP. So you take the same model that you're using to do your daylighting, the same model that you're using to do your detailed hourly simulations and thermal comfort simulations, and then also push that out to PHPP and WUFI-Passive. So, but what is it? Like, what is Honeybee-PH? Fundamentally, it's sort of two, maybe three things. So on one side, we have a whole set of new, what we would call code libraries, extensions to Honeybee. We're expanding and extending Honeybee, adding new features and functionality around Passive House specific envelope and attribute values. As you guys know, Passive House has a very kind of idiosyncratic and specific way of like describing the attributes of a building. And so we need to be able to manage and store those in some way. So we have a whole set of code libraries that allow us to do that. It's a whole universe of Passive House heating, ventilation, and air conditioning equipment, which really doesn't align to any other sort of industry standard. And so we have to have a whole set of code libraries for the HVAC systems, and then a whole set of libraries for different standards. So you might want databases or libraries of materials or equipment or appliances, anything like that. So we have a whole kind of set of libraries of those that extend and expand that existing Honeybee sort of core. That's on one side. And then on the other, so that allows you to build Passive House building information models, right? That allows you to encode data into those models. On the other side of the coin, we have the ability to move data in and out of the Passive House calculators. So we have WUFI-Passive and PHPP. Those are amazing, and they do great calculation work. And we want to be able to push data in and then pull data out of those at will. So we want to be able to build our Honeybee models and then move data in and out. And so that's kind of the other side of the coin. We have what we call the Passive House Exchange library, which is another set of code libraries and schemas that allow us to effectively and flexibly move data in and out of those different tools. So a whole bunch of behind the scenes stuff. This is all kind of like under the hood. These are the engine pieces that make the whole thing go. Now, when it comes to Honeybee-PH, though, you're not going to you don't really need to worry too much about the behind the scenes stuff. What you're going to be fundamental as a user, what you're most interested in are the modeling protocols and the modeling approaches. So I want to talk a little bit about our philosophy of modeling and how we've sort of used that to shape the tools, or why the tools have the shape they have. Now, first of all, I believe, and this is not something I came up with, but I just agree with others who have said this, the model in quotes, should be free from the application. We do not want our model, our building, to be wedded to or tied to any specific application. We don't want to make a Revit model. We don't want to make a Rhino model. We don't want to make a SketchUp model. We want to make a Passive House model. And that Passive House model should be able to flow seamlessly into and out of any calculator I want and any visualization or editing tool that I want. I should be able to hand that model around between all sorts of different calculators to do whatever I need at that moment in time. Maybe I want to do detailed hourly simulation. Maybe I want to do embodied carbon calculation. Maybe I want to do annual energy calculation. Maybe I want to view it on the web. Maybe I want to view it on a desktop application. None of that should matter. You should be free to move that model in and out. And so building on top of the Ladybug tools, what we have in Honeybee-PH is we have a software agnostic model. So when we talk about the model, what we're really talking about is nothing very fancy. It's just a prescribed way of describing your building. So we have what we might call a schema. We have a recognized and organized method of recording the data about your building, and that data is recorded in a way that's both human readable, but more importantly, machine readable. So a computer can read this model, interpret it, understand it, sort of unpack the model, as it were. And this model exists, as you can see here, in a simple text file. That's all it is. So, if you're familiar with Energy Plus or something, you might know IDF files, OpenStudio, you might know OSM files. It's really not much more fancy than that. In this case, it happens to have a specific format, a HBJSON, but that's not really important. What's important here is that it follows a predefined and understood schema for organizing the data, which is agnostic and independent of any specific application. So we can move it in and out of applications at will. So that part is nice. But on a day-to-day basis, how are you actually going to build these models? You're not going to sit around writing these models sort of one at a time. Although I've heard that people do that in Energy Plus land, and that really just blows my mind that you would like write these things out in text file. In any event, most of us, 99% of us, want some sort of a modeling tool that we can use to build these models, right? So everything I just described is kind of under the hood or behind the scenes. What we want as users is a nice user experience for building up these models for our actual project. Now, in our office, we really like the tool Rhino 3D. So Rhino 3D is our preferred tool of choice. And so that's the tool that we've built out the most user interface components for. And that's purely just a matter of that's what we like. Again, the model and the Honeybee-PH tool, they are not wedded to Rhino in any way, shape, or form. They are software agnostic. But we like Rhino, and so we've built out a whole universe of specific tools to allow us to build up these Honeybee-PH models using Rhino. Rhino 3D is just a 3D modeling application, in my estimation, very flexible and a great choice for this kind of work. Now, Rhino has a kind of a sister application known as Grasshopper. I know lots of animal names here today. And Grasshopper allows us to build up these detailed data models, which refer to our 3D geometry. So you have these kind of parallel applications running there. The workflow is quite straightforward, right? So if you have your 3D model in Rhino, and then you have your data model or your attribute model being built in the Grasshopper tool, you might add new components to that tool. So for instance, here we might add a ventilator. You might give the ventilator then some attribute information. So for instance, maybe you want to give it a display name, so keep track of things. And then maybe you want to give it some attribute information like a sensible heat recovery value. So those kind of things would get added and defined within that data model. And then the way that the Honeybee-PH tool works is you can then open that data model up in WUFI-Passive or PHPP. So here you can see opening it up in WUFI-Passive. So you simply open up that XML file, which was generated. And if all goes well, you'll see that my vent equipment with 83% heat recovery has now been added to your WUFI-Passive file. Right, so the data flows from that 3D information model through the data model into the calculator. You can then run your WUFI-Passive calculation, see what your results are, and if you need to make changes, you go back and make those changes back in the data model there. So that's the sort of typical workflow that you might see. Now in Grasshopper, what we have developed over the years, and again, this is just sort of because this is our tool that we work in, is more than 100 different components that allow you to manage things like assemblies and materials and windows and shading and thermal bridges and foundations and residential or interior spaces. Space level program information, lighting and occupancy, ventilation equipment, ducting, hot water equipment, piping, heating, cooling, and on and on and on. So there's, as I said, more than 100 different components that allow you to manage different aspects of the data of your project. These components are all very, very flexible and allow you to move through your modeling process very expeditiously. Now, there's a second part to our belief in how these tools should be structured. So I said that the model should be free of the application. And I also do believe that the data of your model should be free of the actual model itself. So the data for the model, the actual specific heat recovery or sensible heat recovery value there should actually not be encoded just the way I showed you by typing values in. I mean, it can be. That's not the end of the world. But I believe that you're much better served by taking that data out of the application and storing it in some sort of database or CSV or Excel file somewhere else, and then pulling it in to your model when you're ready to export. So in our office, the way that our workflow works is we have an external database which stores and manages, cleans, organizes all of the project data. The project data is then referenced into the model, and using that Rhino application, we can then push that data out to both the Passive House calculator, in the case here, WUFI-Passive, but also the document model. So everything now is linked together and woven together, and we have this new database repository in the series here as well. Now you can use whatever database you want for that. We happen to really like a cloud-based database known as Airtable. There's no particular reason other than it's a collaborative kind of online database, so multiple users can use it at the same time. It's really transparent, really flexible. It's not an advertisement for Airtable. You can use whatever system you want, but we have a whole bunch of components that allow us to host our data on Airtable. So for instance, we want to store the heat recovery efficiency of a specific ERV along with its cut sheets. We want to pull that in to our Grasshopper model at runtime so I can reach out across the internet, grab that data, pull it into my Grasshopper model, and then that data flows through into my WUFI-Passive model as well, or PHPP as the case may be. And if I need to change something, I go to that online repository, I make the change, and that flows through everything there as well. Now, one thing that we really like about organizing data outside of the software is that gives us a lot more flexibility for storing the justification documentation, the supporting documentation. One of the big failures, not failures, that's a harsh word, but one of the big issues or frustrations with current tooling is that we can't just store the justification documentation along with the data point in the model. And what I really want in WUFI-Passive is a little button that says upload PDF, and I can add the PDF for the thermal bridge right there in WUFI. But instead, I have to keep this other PDF somewhere else in a Dropbox file somewhere. And that sort of linkage is quite frustrating. This is not a perfect solution, but at the least we can store our justification documentation in line with the data item in the database. So the database allows us to store that information, and we can then flexibly sort of clean and organize that data much, much better. So we're using this method of database storage for all of our room data, all our ventilation equipment and pumps and fans and appliances, all the heating and cooling equipment, material information that's shared across everybody on the team, assembly layers and constructions, thermal bridges, window frames, glass sizes, and on and on and on. All that data is now stored in this online repository, and we pull that in as needed into our actual Passive House models. So what that means in practice is when you're modeling, what you're really doing is not so much defining specific values as you are establishing relationships. So you establish relationships, and then at any moment in time, you should be able to swap out the underlying data, and the building should more or less shape itself based on that underlying data. And if we go down that route, what we have found in our own practice is that we see a lot more comments like this and a lot less comments like we saw before, where so-and-so value doesn't match so-and-so value. Right? So this is what we want to move towards, a more automated, clean, organized, less labor-intensive method of getting the right values in the right places in these Passive House calculators and across the board, whether we're talking about WUFI-Passive or PHPP. Let's just finish up the last couple of bits here, and then we'll leave some time for questions. So what can we do with Honeybee-PH right now? The main use case, as we've talked about, is about moving BIM data into or out of those Passive House calculators, whether we're talking about WUFI-Passive or PHPP. So the Passive House Exchange library allows us to move that data from our modeling environment into WUFI-Passive and into PHPP. Now, the most well-defined and sort of mature of those workflows is for Rhino. But again, this is all software agnostic. So, it can work with whatever your sort of application of choice is, provided that there is a Ladybug Tools interface there. So that's probably the main user story, the main workflow that main utility that most people would get from Honeybee-PH. Now, because though we have the ability to move data in and out of our calculators, what that means in practice is that we can actually do all sorts of other things. What you're seeing here is an example of a typical client-facing product that we make for one of our consulting clients. We use a web-based reporting methodology or reporting kind of template here. And a lot of this is generated automatically from those Passive House calculators. So it's not 100% automated. You still have to go in and do the writing and do the evaluation. But a lot of the graphs, a lot of the graphics are all excuse me, are all created automatically using that PHX library. So that significantly shortens the time required to do these types of client-facing graphics, right? If you can standardize those and automate those processes using these types of behind-the-scenes tools, that can significantly improve your overall workflow. Of course, things like typical architectural graphics are also going to be required in many cases. One of the nice parts here, though, is because we're building, and this is not like revolutionary, right? This is just BIM. Because you're building a rich BIM model, you don't do things like write in the name and a tag. You just use a tag object, which is able to pull that data out from the underlying BIM object and create these types of documents automatically. So that's a really important part of the workflow. Again, what we're trying to get here is alignment of documents and alignment of data across everything that our certifiers might be looking at. So they might be looking at PDFs, they'll be looking at the 3D model, they'll be looking at the Passive House model, and they want to see the same data in every single one of those places. So automatic generation here is important. So that all works right now out of the box. We use all of that every day to do our projects. But we've got some interesting sort of proof of concept and sort of experiments that we're working on and that we think that the Honeybee-PH tool might help us with in the future. So the first of those might be other client-facing documentation. And so what you're looking at here is a proof of concept of a sort of client-facing dashboard that we might use for, let's say, a commercial project with many, many ERVs and many, many different products. The goal here is to get all the data about the project at the within the or at the fingertips of the client right away. The important thing to understand about what you're looking at here is you're not looking at some other thing that we had to make. What you're looking at is the database, is the data of the Passive House model. And that's because we put all that data in that cloud database. And so I can look at it through the standard Airtable interface, but I can also make a whole other dashboard that grabs that data off of that cloud database and just repackages, shows it differently to the clients. So you're not looking at a thing that anybody had to create. You're just looking at a different representation of the underlying Passive House data. Right? And that's important for giving live visuals of the existing data. You don't want somebody to have to every week like go in and update this, because that'll never happen. Right? And so this is a live view of that existing data. One of the other places that I'm really keen to develop in the future as well is to really extend the utility of that sort of text file, that text version. I think it's probably obvious that I am frustrated with the whole idea of like maintaining a separate pile of PDFs and like constantly like pointing to them and being like, look over here, look over there. Why can't we just embed that data directly in the HBJSON so that when the certifier goes to review your project and says, hey, do you have documentation for that window? That documentation is actually associated or connected to that window object. So being able to pass that justification data along simplifies both the modeler's work, but also the certifier's work. And so we've got some sort of proof of concepts happening there as well. That's another piece that we're keen to develop in the future, is really encoding and embedding more of that justification documentation within the model file itself. And then, of course, on the transparency front, right? As outside consultants, it's very important for us to be able to communicate and show what we're doing to our clients. And so what you're seeing here is a custom web viewer of the Passive House model. So again, in the same way that that dashboard was just looking at the model, not some other thing that you had to create. This is just looking at the model. This is just another way of viewing that same model. And this allows anybody with web access to go in and query the model. And maybe you want to look at the domestic hot water piping and you want to see that, oh, this one here is the shower, but then this one over here is a sink. And so you want to be able to see all of the data that's actually in the model in a much more accessible format here. So there's a web viewer that we're working on as well, which the goal there is to increase transparency across the entire team so that everybody knows exactly what's in the model and what's being modeled in the state of things. Now, when you start going down that route, of course, maybe one of the most logical things that you might ask is, well, hey, you're viewing the model, but what if I could edit that model? What if I could actually make some simple changes to that model through that web interface and use some sort of cloud able tool like Energy Plus that we could put in a Docker container and put up on a, AWS somewhere? We use that to actually run calculations in the cloud, so that a client or a user can come in and say, oh, okay, so these are the surfaces, but maybe I want to adjust the U values for these different surfaces. That'll go off and run calculations. And then I want to see heating or cooling energy, or maybe cooling internal gains or cooling demand right in my web browser there. So it's never going to be a fully fledged Passive House model. It's never going to have the capabilities of PHPP, but maybe you can expose some simple scrubbers to your clients to let them monkey around with some of the U values. They can do their own optimizations, or they can do some small experiments and the like. So that's all stuff that's sort of in the works right now, things that we're working on and sort of toying with, as well as a bunch of other ideas. So if any of that sounds of any interest, I would love it if folks would be interested in using the tools. You can get them. As I said, this is all free and open source. This is not a product. This is a project. You can go to passivehousetools.com and download the installer today for the Grasshopper tools. You can grab those and start using those right away. And I would also say that, as I said, it's all free and open source. So if you are at all interested, we would love to work with you on anything that you're interested here. As far as the project, whether that's building new features and writing code, or writing documentation or testing, building tutorials, helping us with the website, graphic design, branding, any aspect of this, it's all a free and open source project. And we would really love any type of contributions that anybody might be interested in making there. So we would love to have you join us. You can, get in touch with us any number of different ways, but maybe go to passivehousetools.com there. That's probably the easiest way. Now, the last piece here before we sort of take some questions, Okay, yeah, that kind of sounds interesting, but it also kind of sounds like a lot. So let's say I don't have any experience with this. How exactly do I go about learning this? So this has been one of the most common questions that we get from folks when it comes to Honeybee-PH is how do we begin to learn these tools? They sound sophisticated and kind of challenging. And so how do we learn more about them? On that front, we have recently partnered with the Reimagine Buildings Collective in order to create and distribute a new series of on-demand video trainings around the Honeybee-PH tools. So if you're not familiar with the Reimagine Buildings Collective, you can take a look at their website here. I'm sure Zach can also tell us a little more. But the Reimagine Buildings Collective has a series of members only on-demand video. So currently we have a pretty extensive up and running with PHPP course. That one already exists. You can jump in on that today. And as of today, as of this recording, we are now opening up two new series, one Honeybee-PH for PHPP users and another Honeybee-PH for WUFI-Passive users. These extensive tutorials have, I think it was over 30 hours of recorded video around all of these different aspects. So if you have not gotten enough of my obnoxious voice, you can listen to 30 hours of me ramble on about energy modeling. We start with Rhino 3D modeling, go in depth with the Rhino 3D interface and geometry modeling. We'll look at that whole grasshopper environment and talk about how we use that and what that's used for. We go in depth on the Honeybee modeling process. We look at Honeybee Energy, the Open Studio, and Energy Plus simulations, those detailed hourly simulations. And then we branch off to look at how we can use Honeybee-PH either within the context of PHPP or WUFI-Passive. So it works very similarly for both, although there's some nuance to the way that we would model them differently. So both of those paths are going to be available as of today, and so you can jump right in. I would also note if you're interested in any of this, if you're not already a member of Reimagine Buildings Collective, keep an eye on that. We have grand plans to build all sorts of other members-only video series around things like thermal bridge modeling, interfit modeling, multifamily with Honeybee-PH, non-residential with Honeybee-PH, advanced data management, scripting, what have you. We've got all sorts of ideas for other courses that we might build over the future. So if you're interested, definitely check out reimaginebuildings.com. Join us today. It's a great platform, a wonderful place to connect with other Passive House practitioners. And then, of course, you do have access as a member to all of these video tutorials as well. So with that, I will come to a close here, and I'd be more than happy to take any questions that anybody might have about what we've talked about today.
All right, I'm going to roll right into questions. First, to knock out maybe two easy ones, kind of yes, no. Will the new version of WUFI, the cloud-based or web-based meter be supported by Honeybee?
It's a great question. We would love to support meter. There's no reason that we can't. Right now, I think the only workflow that would work like today would be the thing where you open it up in WUFI and then save it as a meter JSON file. There's no technical reason that we can't create those JSON files directly and so that you could upload it. But we would have to we just have to do the work to do that. We haven't we haven't yet gotten our hands on meter, so we don't actually know how it's set up or what the data format looks like. There's not really, I mean, as with all these tools, there's not really any documentation. There's no software developer kit. So we kind of have to like reverse engineer it because it's it's a closed source thing. It's not an open source project. So we kind of have to pick it apart. So we would love to support that in the future. We definitely will in the future, as eventually Fias will switch over and stop using WUFI entirely. That's a few years away though. So yeah, at some point we will make that switch and make sure that works, and we'll generate those JSON files instead. My big hope was that we would be able to have like a public API for meter so that rather than making a JSON file and pushing the entire thing, you could actually like, do it automatically. It doesn't look like we're going to have that. It doesn't look like that's yet a feature of meter. Maybe they'll add that in the future. But yeah, it will get supported. I don't have a specific timetable for when that'll happen, but we definitely will. It's a great question.
Makes sense. And then you alluded to kind of like this next phase of actually making the review process better, both on, directly with FIAS and perhaps with certifiers through PHI. And you spoke about, just generally them having access to like the database component, but how is that going? Are they on board? Is it that you have to ask and make sure that each individual reviewer is willing to like work within that interface, or is it more that you're working towards an automated, integrated thing that that any practitioner can kind of like submit as their normal
Yeah.
as their normal submission process?
More the latter. It's a great question. More the latter. It's more what we have so far is more about internal processes to manage the data. Then we have the ability to repackage it and organize it the way that the certifiers already want. So most of the certifiers that we work with, God bless them, we love them all, are, they have their processes, and we're not really we're not going to bully them into like changing their process to kind of adapt to what we're doing. We would love to work with certifiers who want to improve their processes and move towards more automated solutions. That would be amazing. We would be glad to work with anybody who wants to do that. Our experience has mostly been that it's more straightforward to just kind of package things up the way they're expecting already, a big pile of PDFs, and just sort of send that off to them. And so typically that's what we're doing. That is that kind of it's not ideal, but it sort of matches what they're expecting to see. And so rather than try and reinvent things with them and force them to, I mean, we can't force anybody to do anything, but like try and get them to work a different way, we generally kind of adapt or try and adapt to their existing processes. But yeah, in the future, it would be awesome if some certifiers like, oh, we want to move to this automated workflow. Like that would be a wonderful collaboration. That would be amazing.
Yeah, but you're just working on the packaging really for it. Awesome. Well, I am not going to hog the questions anymore. I tried to get some that were flowing through. And we have Douglas Massey up first with a specific, I think, integration to SU 2025, which I have no idea what it is. But Douglas, if you want to come on and ask that question, if you're still with us.
I am still with you.
Yeah.
SU is SketchUp. It just came out today. Will it work with SketchUp 2025?
It's a great question. So none of the tooling here has a SketchUp integration, I don't believe. I think the only way, I'd have to go back and check the Ladybug Tools website, but I believe that currently they only support Revit and Rhino, I think. I'd have to go back and check that for sure. But I don't believe that there is a SketchUp integration. However, if you really wanted to go from SketchUp, the way that you would do it would be to use the SketchUp plugin Euclid. So Euclid is the current plugin for building Energy Plus models in SketchUp. So you could build your Energy Plus model in SketchUp that way, and then bring that in and convert that over into a proper Honeybee model that way. So you could do it that way. It's not ideal. You're going to lose a lot of, there's not going to be as much kind of tooling and support around it, but it is definitely possible to do it that way.
Okay, thank you.
Sure.
Douglas and Caleb, you had a few questions.
Oh yeah. Hey Ed. Great
Caleb.
to see you. I mean, I think your front end where you were really describing a lot of the problem was like brilliant, and like always inspiring to see the forward thinking into the whole digital ecosystem that we've got. And because it's like most of the mistakes that I see in my daily like review of energy models is like input error. And I think this idea of the database and that maybe shared databases, which, like the eQuest community actually has like this sort of big, robust kind of like workarounds for different kind of modelings, but it's still workarounds, and I still see these same database errors. But I had sort of a question, like the first question was like is Grasshopper going to actually become something more native to Revit? Because from what I understood from what you said was that it's actually a converter. It's like it converts back and forth between Revit and Rhino, so that you're basically running it in Rhino, but you're taking, is it just geometry you're taking from Revit, or are you taking BIM data from Revit and bringing it in also with the converter?
Right. No, it's a great question. So there's two ways to do it. and admittedly, we don't really use Revit, so I am not an expert on this front, but there's two ways to do it. One of them would be to use what's called Rhino Inside, which is a way of connecting Rhino and Revit together so you can pull data out of the Revit model and use it to build up your energy model. That's maybe not ideal for most teams, kind of overly complicated. By contrast, there's another way to do it, which is to use the Pollination or Ladybug Tools Revit plugin. That's a native Revit plugin that allows you to build your energy model right in Revit and then create a Honeybee model out of it there. It uses a whole different methodology, right? This is one of those things that the Ladybug Tools guys have been working on for 5 years now, is like, how do we translate these insane Revit models into an actual energy model? Right? There's a ton of places where you get issues and failures and problems, and they've been working on those problems for a long time now. And so you can use that Revit plugin in order to automate that conversion to a Honeybee model. Now, what we don't currently have is the ability to add in all the specific Passive House flavor data in Revit. So for instance, like a psi install value for a window, right? Like there just isn't an input for that right now. There's no reason that it can't be. Again, it's just not been on our to-do list. It's not been something that we've worked on. And so we just haven't built it yet. But there's no technical reason why we can't. And so that would be a way to do that, would be to harness those two things together. So two different methods to do that Revit integration there. And I'd probably recommend the latter. The latter, using the Revit plugin, is probably going to be the better solution for most teams. That's going to be a much simpler and better way to do it. And and to your other question, yes, it does pull a certain amount of attribute data as well out of the Revit model. So it's not going to be just geometry.
Yeah, because like the Energy Plus modeling side, like, which I assume is what the Ladybug is actually doing with Revit, right? And all of the what you call the Passive House flavored inputs, right?
Yeah.
Like they really discount the envelope in a lot of their calculations. And that may be improving because, like with ASHRAE like 90.1 2022, there's a lot more guidance on it, but it's still not very detailed. Anyway, I'll let the next. I got a million other questions, but I'll let the next person have like some airtime.
No, you're 100% right. I mean, right, with the Energy Plus thing, there's like 75 different inputs values for fan power curves, but you can't model a stud in a wall. Right? I mean, that's the reality of that tool, is that it has a very specific flavor. It is used for a very specific type of buildings that are not envelope dominated, and it has not been the focus of their effort for most of the development cycle. Maybe that's changing, but you're absolutely right. You kind of have to use it in a different way if you want to use it for envelope dominated buildings like Passive House buildings that we're sort of trying to design here. Absolutely.
Yeah, I mean, area weighted might be a solution, which is something I'm actually exploring at the moment. Like I'm developing an area weighted tool, so then those modelers that are using Energy Plus or eQuest can just plug in one number.
Right. So
that they get from the design team. So then the design team has to indicate what those values are, and that's where our big disconnect is.
Yeah. Well, right. So those kind of tools that you're describing are built into the existing Grasshopper toolkit. Yeah. So for instance, if you want to get an equivalent thermal conductivity of a wood stud wall with, 24 on center spacing and a double top plate, right? We have like a single component, and you put in one number, and then you get an equivalent, Energy Plus out of it. We've also stored all that detailed information so that when you take that Energy Plus model and send it to WUFI-Passive, it's able to pull the stud back out, essentially. So you're kind of getting both. And that's kind of a pattern that you see with a lot of this, is we're simultaneously creating an Energy Plus model and a WUFI model and trying to find equivalencies across both of them, or PHPP model, try and find equivalencies across both of them.
Great. Thank you.
All right, thanks, Caleb. Carmel had to run, so I'm going to take over the concierge role here for Q&A. And next up, we have John Snell. John, are you able to unmute? Hey,
sorry,
great.
I don't unmute myself. Hi.
Yeah.
Thanks for taking my question. Great presentation. A quickie question and another one about climate change and the widespread adoption we need to are slowing down climate change. If we, for people already using Rhino, if we use Honeybee-PH, do we need design pH?
You would not. It's a great question, right? So So essentially, Honeybee-PH is a drop-in replacement for Design-PH. So you can shift all of your workflow over to Honeybee, PH, and Rhino. So it does all the same things plus a whole bunch of other things.
Okay, great.
Now, this is a little bit of a nuance, though. However, if you're doing certification with PHI, they will still insist on using Design-PH for the shading algorithm and calculation only.
Okay.
So they will not accept shading calculations from other than Design-PH. So in some sense, even though you can do it, you're not allowed to if you're working on a certification project. Now, hopefully we can get over that hump someday. We would love to work with PHI or anybody on the certification team to come up with a method of allowing us to do other calculations. If they, again, a lot of this goes back to the fact that none of the existing tools are open source. We don't know how they implemented shading calculations in Design-PH, so we can't match it. We would love to. We would love to just replicate it, but they don't publish it. It's not open source. We can't see it. They don't share it. So we're kind of at a loss to say like, well, we would love to do it, but you guys have to, if you published it and told us how it was done, we could absolutely re-implement it in Rhino. So anyway, that's a long discussion.
Let me address another issue that you mentioned, which I loved at the beginning. Climate change propelled a lot of us into passive house design, and where the expensive passive house certified windows limit the widespread adoption that we need for affordable housing. There are problems in modeling the North American windows from the NFRC window database in passive house. Are we able to bring in NFRC data like U values and solar heat gain coefficient, air infiltration into Honeybee? And great.
Yep, that's exactly right. Now, again, a little nuance. You would not be able to use those values for PHI certification. So that's going to be one of the things is you can model it and it will perform, but you will not be able to certify it with PHI, unfortunately.
Well, I think what's needed though is a way to show a client, here's the cost of getting in a passive house certified window, and here's the performance. Right now, I can't compare that. Here's the cost of a NFRC window, and here's the performance, and I can't compare that in FIAs. And I need to be able to do that to justify to the client why they should spend the extra money, or if they don't have that kind of money, if that's just not in the budget, what can we do? How can we improve this?
Good point. Yep, absolutely.
Thank you so much.
Sure.
I love this work. This is great. And I recommend Rhino to anybody. It's so much easier to use than Revit.
Agreed. It's a great tool. Yeah.
Awesome. Thanks, John. Next up is Atman. Are you able to unmute? Looks like you're here. I'll wait a moment. If not, I can ask the question for you. Okay, so Atman asks, is there a live sync feedback with WUFI? Meaning if I change the model, it updates in real time in WUFI.
Yeah, wouldn't that be cool? Not currently, no. So this goes back to my earlier comment. WUFI-Passive is a closed source product. So it has no API. It has no ability to extend. It's completely closed source. You're not allowed, there's no SDK. There's no ability to hook into it or sort of speak with it while it's running, unfortunately. So that's a real significant downside to that software. We were really hoping that Meter would not work that way. We haven't really seen a lot of positive indications. Now, maybe it will, but it doesn't really look that way so far. So currently, the way that it works is you have to save out a WUFI XML file, and then you open the XML file. So you can't really like interact with it in that live way. That would be amazing. But again, that goes back to the fact that these are all closed source proprietary products that are not built for extension. So unfortunately, we can't do that. That would be awesome, though. I mean, we've talked with Florian about it, and he said the same. He was, there is no technical way that we can enable that, unfortunately.
Great, thanks, Ed. And then Diana needed to leave, but asked that we ask her question on her behalf. So the model is translated into passive house requirements in terms of using the thermal line layer for dimensions, ? Walls, etc., which is different to the usual model external line.
Correct. Yes.
Okay.
Yes, absolutely. Yes, you're going to build your model same as you would in WUFI-Passive or like the WUFI-Passive SketchUp extension or Design-PH SketchUp extension. You're going to build your surface geometry exactly the same way. So you would build it at the line of enclosure, not the line of finish, if those are different from one another. So if the edge of your insulation is different than the edge of your cladding or something like that. So that's correct. So you're going to build it that way. There might be a bunch of other differences between the real architectural model and the energy model, right? If you have a subgrade, if you have a basement wall, which is partially above grade and partially below grade, you actually have to split that into two surfaces, one below grade and one above grade. So there's going to be all sorts of places where the energy model is going to be distinct from the architectural model. So those are not the same thing. And so, yeah, you're going to go through the same process as you would with the SketchUp plugins for the existing ones. Great question, though.
Okay, awesome. Thanks, Ed. All right, next up is Julie. Hi, Julie.
Sorry about that.
No worries.
Great work, obviously, and we've been frustrated with not being able to use our Revit model much, but it does look like you're still creating a separate, basically plane series of planes like you would in a SketchUp model. Is that correct? So you've got your basic Revit model, but you're creating a passive house envelope
Now,
out
so
of planes.
that's a super interesting question, Julie. So that actually works a little bit differently. So in Revit, the way that it works is the pollination tool uses the rooms. You know how you can make a room, you can define a room in Revit. So it actually uses the room object as the geometry. So it sort of turns those rooms into the actual enclosing geometry. So the one thing you have to do in Revit is go through and make sure that you're building your rooms properly. But if you've built all your rooms properly, that gets turned into the sort of skin model, the shell model, on a room by room basis. And then they have a whole bunch of tools that they've created to handle things like, if they're off by an inch or something, or like the gap where the floor cavity would be. They have a whole bunch of automated solutions to kind of like fill in the gaps and fix those kind of things. And so again, that's what those Ladybug Tools guys have been working on for 5 years now, is a sort of method of taking a Revit model and turning it into a clean energy model. And that uses a whole different method than SketchUp or Rhino. So it's going to use those room boundaries as you're defining elements.
The exterior wall, if you have a window in that room, that's where you would assign things to that window, or am I not understanding it right?
Yeah, no, that's right. So it's still gonna, as far as I understand, it's still gonna use the information from the enclosing elements, but as far as the geometric boundaries, it's gonna use the room edges or the room boundaries as the defining element there. So it somehow weaves those together. It somehow puts those two pieces together, as far as I understand it.
Thanks.
Of course, absolutely. I should note, right, we're not at Revit experts by any stretch, but we don't have a lot of experience using that Revit tool. So I'm just speaking from what I understand based on what I've seen from that plugin, from that tool. So we use an entirely Rhino-based workflow, but my understanding is that the Revit one would work.
Okay, great. Thanks, Julie. So next up is Debbie Coleman.
Oh, hi. Thank you. I wasn't sure you were going to be able to get to my question. Yeah, so I was concerned about it seeming too complex for a single family residential project. And I wonder if you have any examples of people using it in a simple, say, 2,400 square foot home.
Oh, it's a great question. So, I mean, I can say right off the bat that we use it for every single one of our projects, and probably 50%, 60% of the projects in our office are single family homes of the scale that you're describing there. So we use it all day, every day for every single project, whether it's a single family home, an ADU, or apartment building. So the tool is able to scale effectively one way or the other. Now, to your other point, yeah, I'm afraid you are correct, right? So this is a complicated professional set of tools for professionals who do dozens or hundreds of passive house models a year, not for the new practitioner who is doing their first one, admittedly, right? So you're 100% right. That's absolutely something we would love to work on, is a more intuitive, friendly, user-facing tool that is more amenable to new users. That would be a great project. Someday I hope that we get there. Right now, though, what we're working on are these sort of data-focused professional tools for, again, folks who are doing their like 75th WUFI model, not for folks who are doing their very first one. So you're 100% correct. That doesn't mean that we don't want to work on those questions in the future. It just means that's where we're at right now. I would also note, the stack, we totally recognize this, and it would be awesome to try and work on this, but the stack is big right now. So like, you have to know how to do Rhino modeling in 3D. You have to know how to use Grasshopper. You have to know how to use Honeybee. You have to know how to use Energy Plus, and then you have to know how to use Honeybee-PH and PHPP or WUFI-Passive. That's a lot of software to learn, right? I mean, that's a lot to understand and sort of cram into your brain. We totally recognize that, but that sort of is the current state of it. And hopefully we'll get to work on simplification methods in the future, though. You're right.
Okay, yeah, and that would be my question. I really appreciate all the energy and expertise that's gone into these connections. But I guess just a final question, would you see either yourself or do you know of another group that might be developing something simpler, maybe with a SketchUp base, say in the
Yeah.
next couple years? Do you know of any intention for that?
It's such a good question. I don't know any off the top of my head. There are a couple of interesting movements in that front. So on the PHI side, they have released something called Easy-PH, which is a sort of a truncated, simplified version of the PHPP Excel workbook there. On the FIA side, they released their prescriptive method a year or two ago. They have a kind of a simplified Excel calculator that you input those items in. Neither of those are super well integrated into the 3D models. I don't even know if they are at all integrated into the 3D models, the BIM models, to be honest. But that would be awesome, right? If those kind of simplified products were made available to folks through tools like these. I think for the foreseeable future, and that's a really interesting question because this kind of goes to like, who's the main market for Passive House? For the foreseeable future, and certainly the tools that we're making, the assumption is that there's going to be a CPHC who's going to be a certified Passive House consultant who's going to build the main model. So even that 3D interface I was showing you, the kind of assumption there is that you had somebody who's really knowledgeable and experienced build the model and then expose a couple of handles to the users who are less experienced. So maybe you expose a scrubber to change the roof insulation from R30 to R80. You can't go to 0 and you can't go to 1,000,000. You sort of put some boundaries on it, but then you let people sort of play within those boundaries. But that still requires an experienced CPHC to kind of set it up ahead of time. So my guess is that would be the kind of model that you would see over the next few years. Although it would be amazing to see more innovation when it comes to really user-friendly tools. But I don't know of anyone that's really working on that question earnestly, I admit.
Okay, well, thanks for the answer, and I will remain
Of course.
hopeful.
Absolutely.
Thank you, Debbie. And I am afraid we have run out of time. We've gone over here. So Ed, I really appreciate all of your time and of course the expertise and leadership that you've taken to make this course happen, and to make the tools happen. So thank you all for joining us today, and I hope everyone has a great Wednesday. Ed, do you want to say any last final words of wisdom?
Just again, thanks for everybody for being here. Again, if you're interested at all in this, check out passivehousetools.com. You can learn more there. And I really look forward to hopefully seeing you as part of the video course over at Reimagine Buildings. It'd be a lot of fun to go through this, and I hope it would be a valuable and helpful course for those of you who are interested in any of this kind of stuff. And again, if anybody wants to collaborate and work on anything here, feel free to reach out at any point. It's all free open source, a project that we're working on. We'd love to work with folks on it. So get in touch and we're happy to chat.